Let's talk about finding that constant of proportionality, which is also the constant ratio, which is also the constant rate of change. Just it's special when it's a proportional relationship. Okay. First thing I always do whenever I have a graphic, so a graph, a table, a map, anything, the first thing I want to do is just kind of give myself some context here. So when I'm looking at my graph here, I'm looking at the title is water use. I'm looking at my axes, so it's showing me water used over time, right? So I want to be able to tell myself I'm also looking at my scales here. So I see that my x axis is counting by 1, but if I look at my y axis here, I see that it's counting by 5. So I want to keep all of that in mind, watching for that as I begin thinking about this question. So I want to calculate the constant of proportionality. And to do that for a graph, I'm going to find two nice points. First thing I want to know is it proportional? This graph is linear, it's a straight line, and it goes through the origin right there, right? So straight line through the origin. Those are the two qualifiers. So I know that it's proportional. I'm going to prove it by picking 2 points and showing that the constant ratio, the constant of proportionality is the same, right? When I say 2 nice points, that's just points you can name. Okay, because there's lots of points on this graph. I could say this point, I could say this point, but those points, I don't know the exact coordinates. I would start making up that I'm like, oh, that might be like 8.2, right? And we don't want to make up points. We want to pick up points that we actually know what those coordinates are. And those are usually at the intersection points, right? Like intersect nice, clean, where I can name it. So I could name this point right here because I know it's at 210. Remember X, then Y. I could name this one, that's at 315. I could name this one, that's at 735, right? I could name any of the nice ones. I could pick this one or this one. Those are at intersections. So let's just go ahead for this one. We'll pick these 2 points, right? So I'm going to use those just to prove that what I think is proportional is actually proportional. All right, so we do telling myself, okay, this is xy. To find the ratio, I do y divided by x, y to x, okay? So this goes 10 divided by 2, which simplifies to 5, okay? This one is 35 over 7, which also simplifies to 5. Woohoo! These are the same, so that's our constant of proportionality. That's what we're finding, okay? So cool if we can find it. We proved that it's proportional because the rates are the same. But then we have to, the big part here is, do I know what it means? Okay, and that's what this question is right here. What does the rate mean in context of this story? Not just like random, but like in this story, what's it telling me? A big clue for rate is that y to x, right? So right here, y to x, I look at my axes and those will tell me. So this is gallons to minutes, right? Gallons to minutes. So when I look at that, now I'm going to take that 5 and say it's 5 gallons per minute. That's what it means to tell me the rate with this story. Okay, I'm not just saying it says gallons per minute. I'm saying specifically this one shows me 5 gallons are used per minute, right? So being very specific, clarifying what it means. The equation is going to be y equals the rate 5 times my x values. Okay, and what that equation means, I can come and check that. That tells me for every x value, I multiply by 5, and it should give me the y value, right? So right here, I would have at this point, if I were to do 2 times 5, that equals 10, right? There's my x, there's the y, that's what it's supposed to be, right? Up here, I could do 7 times the rate, that equals 35. X times the rate equals my y value. That's what the equation means, okay? So let's do it again. All right, we have a graph. First thing I'm looking at is what is it telling me? So it says hiking distance. I see my y-axis tells me my distance in miles. My x-axis is time. I'm looking at what's it counting by. Each of these lines is 2.5, right? Because 2.5, 5. So then that's 7.5, right? So knowing it's counting by 2.5 on my x, and then I look at my y, and I see that those are counting by 2. All those things I want to look at. And the other thing I'm looking at is what kind of graph am I looking at? It's a straight line, so it's linear, and it goes through the origin. So this is a proportional graph. Yay! All right, so we're going to pick 2 points we can name. So at those intersection points, right? So I can do 5, 6. Okay, I can do 10, 12. Those don't have to be the ones I use, but they can be. Okay, so I'm going to use 5, 6, 10, 12. And then I'm going to find that constant ratio and prove that this is proportional, right? So there's my x and y, helping my brain be happy. All right, so y divided by x, 6 divided by 5. Okay, that's as simple as it goes. I'm going to say what the decimal value is, right? And let's do 12 divided by 10. Both of those can be divided by 2, so that becomes 6 over 5. Hey, that matches. Yay, it's proportional. Okay. There's going to be times where you want the fraction. There's going to be times where you want the decimal. It totally depends on the story. But that 1.2 is our constant of proportionality. That's the rate. That's our constant ratio. Okay, all of those things. That's what that means. All right, so now we have the number, but now telling it in the story, what's that mean? So again, we look at our y and x axis, right? This is y is my miles, and x is my time in hours. So this is miles per hour. So I take my number that I found, 1.2 miles per hour. Okay, and I use the decimal here because 1.2 miles makes more sense to my brain than 6/5 miles per hour. So we just, being flexible, I could put 6/5. The equation is y equals the rate, 1.2, times the x value. And again, if I did my x times the rate, that gives me my y value. X times the rate gives me my y value. Okay. All right, let's look at this in tables. So in tables, I'm looking, this tells me cost of tickets, right? So I'm going to find that constant ratio, y divided by x, and make sure that it's the same. 5 divided by 1 is 5. 15 divided by 3 is 5. 25 divided by 5 is 5. Yay, I love when it's proportional because that's all I have to do. It's really nice, right? The way you check that is just 1 times 5 should be 5. 3 times 5 should be 15. 5 times 5, right? If I multiply by the rate, that should get me there. All right, these are the same. So my ratio is 5. That's the constant of proportionality, or the ratio, or the rate, okay? Interchangeable. And then we want to know, well, what does that number mean with my story? All right, so remember, we come and look, x, y, right? Y to x is cost per ticket. If I put my labels, it helps with this rate part right here. $5 per ticket, okay? And then the equation, we put it all together. Y equals the rate, 5 times x. And we just proved that when we did this right here. That's our proof. X times the rate equaled y. X times the rate equals y, right? Proving it over and over and over again. So let's try one more. First thing I look at is the story. So this is telling me cost per pounds of bananas. I'm going to get my X and my Y right here. Okay. And we want to find that rate of change, our constant ratio. All right. Don't be afraid of the decimals. Okay. When you divide that out, that's 0.75, 5.25, divided by 7 is 0.75. You could do the math off to the side, right? All right, so I'm super happy. It's all working out. Yay, right? Doing that math so that I can figure out if these aren't the same, it's not proportional. This just proved that this is a proportional relationship. It's a multiplication relationship, okay? So 0.75 is the rate, or the constant of proportionality, or the constant ratio, right? So now let's talk about that rate in terms of this story. All right, so I'm going to come and look again, y to x, y to x. So cost per pound of bananas, right? So the cost is 75 cents per pound of bananas. Being able to be specific with those rates, telling myself what does that number mean is really important mathematically. Okay, so the equation y equals the rate 0.75 times my x values, right? And the way we check that is 3 times 0.75. That should equal 2.25, right? X times the rate equals the y. 7 times 0.75 equals 5.25, right? And that's true everywhere in here. That's how you check, is my rate correct? Does my equation work? If I plug that into my table, into my graph, does that give me my y value? Okay, that's how you work with constant proportionality.